Okay, we have Tim Wilson, EHS manager, Steve, he's with the planning group, Mick, our tool maker, Gary, he's our quality specialist, and Ryan, he is an assembly operator. Okay, today I'm going to talk to you guys about wastewater treatment. There are several inputs, processes, and outputs that go into the treatment system, and I'm just going to explain some of them to you guys. The first input is TiCad plating, and in this bath, there's an electroplating process that goes on. There's a relationship between the part in the water that allows this part to be plated
How does that process work? Is one electrically charged and then?
Yes, the part is negative or positively charged, and then the water is the opposite of that. So it's an electrical relationship that happens between the two. So once that plating bath, once that happens, it comes back to wastewater treatment, and we do a process called cyanide destruction. Because there is cadmium, cyanide in this plating bath. The rinse waters that come back will carry all of that in it, and we will destroy the cyanide that comes back. We do that by adding bleach, and once that is a two-stage process, once that happens, it goes into a holding tank, and that's where our output is. It's water just with some cadmium in it, because we destroy the cyanide in the process. The next input is the chrome conversion. This is following the TiCad plating. That has to happen first so that the chemical conversion can happen with the chrome. We do the chrome process to allow paint to stick to the part. If we don't chromate the part, no paint will stick to it. So we do that for that reason. The next process for that is the chrome is hexavalent, which is chrome 6. And we're wanting to reduce chrome 6 to chrome 3 so that it's not hazardous, so that we can continue to process it and move it on. That's just a one-stage process. We add sodium bisulfite to that, and it can make that reduction happen. The output for that will then be the chromium and the water bath that will be held until we can send it out. The following input will be our acid alkaline bath. In this bath, it's exactly as it says it is. It's either acid or an alkaline based water that comes back to us.
Is that just one tank?
No, there are several. There are several rinse tanks. Once that comes back to us, the process that happens here, we do elementary neutralization, and we have a process to remove solids. The first thing is, in our first tank, we add the coagulant that allows the solids to become big, and we also drop the pH. The second stage, we have a higher pH where it allows those solids to kind of get in the water and we can see them. So the coag makes those solids big and visible in water. The final process of that is our flocculant tank, and the flocculant tank adds it makes those solids heavy. So it bonds it all together, and instead of making it, just still suspended in the water, it actually drops it out. So once this reaches here, and we get, we've had these two come in, and we have these outputs in holding tanks, this all comes together. Like, this is all one process, basically, at the end of it. Once this has been ran through, then this all comes together here. So we are adjusting the pH, because those waters that have the chromium and cadmium in them, they'll need to be adjusted accordingly for those processes. So it all comes here, we get the coag added, the flocculant added, and it goes into our clarifier or our settling tank. The settling tank allows those solids to fall at the bottom, and the clean water stays on top. That clean water will then overflow and go to our scavenger system. The scavenger system is there. It's kind of like a polishing, a water polishing system. It will take out and remove any cadmium or chromium that's left over. Now, in all honesty, we would love to get to 0, but we cannot. Our discharge limit will never be 0 for cadmium. But because of the scavengers, the resin in them, the things that it does, it will pull out so much more and get us that much closer to our discharge limit. We have a pH limit that is 5 to 11, and we make sure that that pH range, after that leaves the scavengers, is set at that point, at that range. So if it goes above or below, it shuts the system down. And then we also have the low discharge limit for cadmium. Again, we would love for it to be 0, but it won't be. But it is always, we make sure it's always below that. Once it leaves there, it goes into our flume and out to the city. And that's basically our wastewater treatment system and what it does here at this plant. Does anybody have any questions?
Yeah, at the end of all three of the processes, do each one of them have a result of having water and solids that you have to get rid of?
Yes, yes.
So it's not just the acid alkali
No,
that results in a solid?
no.
Okay.
So once this process, once it gets all the way through here, we have holding tanks for these two processes. So we hold this water, we check it, and then we send it on through. Now it'll come here first. It'll come to the acid alkaline side of the process.
Okay, so the output of the water with the cadmium ends up
Mhm.
with the acid alkali?
Yep, and the chromium water. It will come over here, the coagulant that will be
It's added to that, right?
Mhm.
Okay.
The coagulant's added here, makes the solids large, then it'll go on down to the next step where it'll be added to the flocculant and it'll make it heavy. So that way we have all the solids at the bottom, we have all the water, clean water going over to the top.
So what do you do with the solid?
The solids, we end up compressing that and we send it out as hazardous waste.
Cool.
Thank you guys.
Kind of comes through as a slurry.
Okay.